Welcome to CV Studies layer. Today we are going to see Maxwell relations. As we know that these relations relate the most of the thermodynamic variables like entropy, internal energy, Helmholtz free energy, temperature, pressure, volume, etc. So these relations are really important for competitive exams. At least one questions for every competitive exams, including chemistry, they will ask this conformly. You can sure that, okay? So JAM, CSAR, even in your QVET exams, like they ask always these things. In case of MSc and maybe in interviews also they ask. So let us see. So the main connecting variables are actually S, H, P, which are actually entropy, heat energy, and your pressure, Gibbs free energy. T is your temperature, then Helmholtz free energy, volume, and internal energy. So how to remember these variables connected by Maxwell relations? So there is a mnemonic. Some hard problems go through an very unusual solution. So in this way you can learn. So instead of EU, you can also say for E. So the mnemonic will go like some hard problems go through an very easy solution. Okay. So these were the things to be noted, the variables in Maxwell relations. Now let us move on to the how to derive them. So the Maxwell relations are derived from the four relations we get from the laws that are thermodynamic laws. So these four things are actually derived somewhere before in laws or in something which was not even correlated with this, but still these four equations are the main block building of this Maxwell relations. Now let us see how to derive them. So let me consider that one of these equations is taken to derive. But before that, we should know that all these equations shown before are actually exact differentials. This means that if an equation is written as dou z equals to m dx plus n dy, then m will equals to dz by dx at constant y and n will be equal to dz by dy at constant x, such that the double differentiation of the function z or z with respect to dou x and dou y at constant x will be equal to the double differentiation of that particular z function with respect to y and x at constant y. So in this way, this is the main thing which is included in Maxwell relations, and this is going to be used to derive these. So let us consider one of the equation dou u TdS minus PdV. So this is from the previous four equations, the first one actually. So let me just take that what is z here, what is x and what is y and what is m and what is n. So as an exact differentiation, differential looks, this has the same format, right? So let me write it. So you have your dz or dou z, then you have your tds or you can say your mdx plus nd, right? Now you can correlate with the same equation. Now you can tell which are the variables. So usually variables are those things which change, okay, with respect to something, or they actually change. So that's why they are called variables. They are not constants, okay? So here the variables are, can you say, first one is u, of course u, but it is a function, right? So now you can see the variables are s and v. Here p and t are or maybe constant, we cannot tell, right? So now here m is equals to your t, if I'm right, and n will be equals to your minus p. So we know that from the exact differential format, m will be equal to your dou z by dou x to y, right? At n equals to your dou z by dou y at x, at the constant x. So now if I correlate with the same, so m equals to t, which will be equals to dou u by dou s at constant v, right? Similarly, if I correlate n with minus p, that will be equals to minus p will be equals to dou u by dou v at constant s. Now one may notice that the same can be obtained when you keep one of the variables as constant. So what happens when one of the variable is constant? So you can see that, let me just minimize this area. So let me take s as constant, right? So my s will be constant, then change in s will be equals to 0, right? Then my dou u will be equal to t into 0 minus p dv. So in turn, minus p will be equals to dou u by dou v at dou means at constant entropy, right? So the same is derived here also. If you see carefully, so the same is derived here, and if I keep v as constant, I'll get the value for t as dou u by dou s at constant volume. So now keeping these things in mind, let me just move on to the next step. Okay, so as I said before, in an exact differential, you'll have dou x by dou z dou y at x equals to dou y dou z dou x at constant y, right? So this may look little bit like I'm talking in Greek alphabets, but still you can learn. Okay, so now we know that x is your entropy, z is going to be your internal energy, and y is your volume, right? So now let me double differentiate the same thing with respect to that this is the internal energy with respect to entropy as well as your volume at your particular entropy, right? So let me do this thing first. So dou s by dou u by dou v at s. So now you guys know that from the previous one that dou u by dou s at constant v is equals to t, right? And dou u by dou v at constant s is minus p. So if I think that use the same, so dou by dou s will be equals to my minus p, right? So it will be equals to minus dou p by dou s, right? Similarly, if I calculated this for my dou by dou v dou u by dou s at constant v, so it will be equals to your dou v t. So my answer will be dou t by dou v. Now using the exact differential theory that these two terms are actually equal, so we can conclude it by saying that minus dou p by dou s at constant t will be equals to dou t by dou v at constant s. So this is only the one of the relation I have calculated. Okay, so this is the first relation I derived from what do you call it as that dou u equals to TDS minus PDV. So now you can also calculate it for other three relations and check with the answers. Now coming to know about the trick which will be very useful in calculating Maxwell relations, as we know that this is really incredible. So first you have to learn a mnemonic called sun please turn violet. So if you learn this, that's enough. So now let me write it carefully. So sun please turn violet. Sun please turn violet. So let me take this on the other side. So now I have this on my other side. Now what you have to do is take any of the three variables. Okay, so let me take like spt. So put an arrow from which arrow you are going. Okay, that is very important actually. So now you have s as the initial one and t as the final one, right? So you have to write like dou s by dou p at constant t, right? Now you can see that my initial one is in downward position to the final one. So it indicates like the Cartesian thing, it's negative, right? So we'll put a negative sign here. Now similarly, what will be equals to this will be just the opposite way. Okay, so if my thing is starting initial is s, so I will start from v, so end at p. Okay, the three variables only. So my answer will be like dou v by dou t at constant p. So now you can see that v is in the upward direction, right? So the thing will be in Cartesian product, it will be positive. So that's why this will be positive, and this is one of the relations we have derived from Maxwell things. So it was such simple. Now let us derive what we let us see what we have derived earlier. If it was correct or not, let us see. So my first one was right. It was like minus dou p by dou s at v, right? So it will be going like this. So as you can see, my final initial are like in the downward position, so it will be negative. So dou p by dou s at constant v, which will be minus, right? So now the answer would be like from t. So my answer would be dou t by dou v at constant s, right? So now if you see that the final one and the initial one are in upper position, so the answer will be positive. So this was the trick to calculate the Maxwell relations. So you can calculate umpteen relations from these, and usually sometimes they ask for like from the direct variables or the functions, like how to calculate from internal energy and all. Don't worry, okay? So first you can see that, as I said earlier, when there is a double differentiation, right? So you have a dou square u dou z, sorry, not dou z, dou s and dou v. So that will surely will be equal to your minus dou p by dou s at constant v, and will be equals to dou t by dou v at constant s. You may wonder how did I say it. So as I said earlier that when this is equal to this one, right? So we calculated this has to be minus p dou s, and this has to be dou t by dou vs, right? So in that way, we have calculated the same. So both actually are the same thing. Okay, they are not different one. So in this way, you can calculate for the functions also. So these were the Maxwell relations. Be take care. Do remember the formula again and again. Practice well for the questions, and just attempt like anything.